we introduce blended primitives, a design representation for machine knitting instruction charts. Blended primitives combine raster-based blocks of stitch instructions and yarn assignments with vector-based paths and boundaries. This creates 4 types of blended primitives: stitch paths, yarn paths, stitch fills, and yarn fills. We built a design tool for editing charts with blended primitives that includes a split pane view of a chart-based editing environment and a synchronized yarn visualization. The yarn visualization includes a particle spring simulation to visualize local deformations in the knit fabric, and also enables inspection of the technical back of the fabric. Under our approach, the global instruction chart is rasterized using the positions of vector elements and their associated stitch and yarn blocks. We demonstrate how blended primitives can be used to design a number of common knitting techniques, including ferile, intarsia, lace, and cables. Additionally, we can design single-layer intarsia-based sensing structures and origami-inspired pleat patterns. Here's an example intarsia design workflow in our editor. We first draw a new boundary, like this circle, and assign it a yellow yarn fill. When we inspect the back of the fabric, we see that the green yarn leaves long floats as it travels across the back of the yellow. We can address this by using a new boundary to make a third yarn knit the stitches to the right of the circle. We send this new boundary to the layer below the circle. This removes most of the floats. We can remove the remaining float by ensuring that there are an even number of rows so that the green yarn ends on the correct side. If this pattern were knit as is, there would be gaps because the yarns are not joined where they meet at a boundary. Sometimes this is desirable, such as when knitting a buttonhole. But to prevent this when knitting intarsia, we include a yarn join boundary condition, which adds tucks when 2 yarns meet at a boundary, cinching the fabric together to prevent the gap. The extra yarn could be knit in the same color as the green yarn to make it seem like the circle could be sitting on an unbroken field of green. Yarn paths and fills can be used to design intarsia-based sensing structures by enabling fabrication of isolated regions of conductive yarn. Here we use boundaries and yarn fills to lay out capacitive touch sensors on the surface of knit fabric. For the conductive regions, we ran a conductive embroidery thread through the same feeder as the yarn. Yarn paths can be used to design conductive traces, here used to make an interdigital electrode. This can be used to sense pressure when in direct contact with skin, as well as humidity. We can use yarn paths to place pressure sensors at the heel and toe of a sock pattern. A similar sensor can be used to sense stretch or bend, which we have used here to make a bend-sensing mitten. We are very excited to continue to improve the blended primitives design environment, and we hope that our open source contributions will enable future collaborations with researchers across domains.